I'm debating the ethicality of human genetic modification and whether or not it should be banned. To start with, what is human genetic modification? It's the direct manipulation of the human genome using various molecular engineering techniques, and it's generally divided into two types. There's somatic genetic modification, which is the modification of the genes in the cells of an adult. So we're talking a human that is already fully grown. And there are various approaches that scientists have taken to somatic gene therapy, including replacing a mutated gene that causes disease with a healthy copy, inactivating a mutated gene that is functioning improperly so that it stops hurting the body, or introducing a new gene into the body to help fight a disease. And this could look something like stem cells. Stem cells are the cells from which all other cells in your body are created. So for gene therapy specifically, stem cells can be trained in a lab to become cells that can help fight disease once introduced back into your body. Somatic modification would not be passed on to offspring, and it's typically used to treat a medical condition. As for germline genetic modification, this is the more controversial one. It's the modification of the genes in eggs, sperm, or early embryos. Changes like these would appear in all the cells of the subject and the offspring of the subject. So germline genetic modification has never been tried on humans, so I can't really cite any examples, but the intention would be to fix, quote-unquote fix, or enhance a potential human. The argument for genetic human modification is pretty simple. Its potential is limitless. For somatic, specifically, we could treat all genetic diseases, or even diseases that aren't genetic. In clinical trials, gene therapy is already reducing the frequency of blood transfusions that hemophilia patients need to prevent bleeding episodes, according to the National Center for Biotechnology information. Genetically modified immune system cells that attack leukemia just became the first gene therapy approved in the United States 2 years ago. Trails are being blazed, lives are being saved. Think of all the hope and relief that the millions of people affected by these two conditions alone have now. For germline, in a perfect world, we could eradicate all genetic diseases. And that's huge. We all know somebody affected by cystic fibrosis, sickle cell anemia, hemochromatosis, or Huntington's disease. This especially hopeless and despairing kind of hurt and hardship that these genetic diseases bring on just wouldn't exist anymore. These wouldn't be problems that humanity has to face anymore. Certain types or instances of heart disease, Alzheimer's disease, arthritis, diabetes, cancer, obesity, epilepsy, and dementia could be heavily reduced. And think of all the people that are affected by those. If everything works as expected, the amount of human suffering that could be prevented would be immeasurable. On top of the prevention of suffering, we could create genetically perfect human beings. We could create super soldiers for defense, human beings built optimally for space and ocean travel and exploration, human beings built optimally for public service or hard labor jobs like construction, savants to solve humanity's intellectual problems. And of course, the humans produced wouldn't be forced into any positions, but the point is that the possibilities for humanity are endless. As for the argument against, for somatic specifically, somatic gene therapy techniques are mostly in clinical trials right now, so we're not even very sure about what we're doing yet. Even then, the science isn't cut and paste across every disease, so very few conditions can even be treated as of right now. The cost is very high, and many insurance companies don't cover it, which makes somatic gene therapy a privileged commodity inherently. And in a world of increasing inequality, this could raise several ethical dilemmas. Again, since the science isn't perfect, it's difficult to find a reliable way to get genetic material into cells and to even target the correct cells. Think about that. This paints a picture. Overall, gene therapy is quite testy and unreliable, and that makes it a breeding ground for mistakes. Take the case of Jesse Gelsinger. He had a rare genetic disease known as OTC. And most kids that have OTC die before they're even 5. But Jesse had a more mild form, and while he wasn't thriving, he was stable with certain diet and drugs. And when he was 18, he died as a result of his voluntary participation in a gene therapy experiment. So you can see this creates a market for people that have a genetic disease and are desperate to do anything to solve it. And that also raises ethical dilemmas. As for germline therapy specifically, it's already banned in several dozen countries, and these are countries with highly developed biotechnology sectors. So they know what they're doing, and it hasn't been tried on humans for good reason. We just don't know what it's going to do. It opens a Pandora's box for a new kind of eugenics. The combination of the high cost plus the potential to create designer babies could introduce a new form of playing God and inequality and discrimination. And these are ones that we might not be able to come back from. As for parents that just innocently want their kids to be unaffected by genetic disease, alternatives exist. Conventional embryo screening and selection procedures are ethically questionable, but they're definitely safer and more ethical than producing genetically modified babies. There's also less potential for widespread societal disruption with screening and selection procedures because the the genetic makeup of the human that is produced is one that would have come naturally, one that we generally know is safe, rather than one that we make ourselves and one that we can't predict. The potential negative consequences also aren't limited to the subject and the subject's offspring. The mother that the embryo is implanted in is exposed to the risk of miscarriage, maternal injury, and stillbirth. Any mistakes that happen during the process could lead to public distrust in genetic technologies, and less funding for genetic technologies for something that's such a potentially impactful area of research could hinder humanity's medical progress by decades. And the bottom line is that you just don't know. Even if a baby is born perfectly healthy and they grow up to have their own babies, they could then find out that the way that their genes were modified debilitated them for life. Now they have to deal with it, and all of their kids have to deal with it. Germline genetic modification could potentially have irreversible and monumental effects on humanity and entire ecosystems.